So welcome you all for today's session. Today we are going to do the transient thermal analysis on the engine component. So first of all, start the ANSYS workbench. So I am going to use the transient thermal analysis. So click on this. You have engineering data, geometry, model, setup, solution and result. So first of all, we are going to create a geometry in design modeler. So select on any one of the plane. Select the units first before proceeding. So create a primitive, say for example box. Specify dimensions for your box. Say I am taking as 30 centimeter, 30 centimeter and 30 centimeter in all direction. Then make it add to frozen so that it will be better visualization. So this is how the object which has been prepared. Now I will go for thin operation over here so as to make this hollow from inside. So I have selected thin surface. Select your faces here. So I have not selected the bottom surface. Make it apply and generate. So from bottom it will be open, as you can see now. Now I'm just going to create fins on these surfaces. So how to create the fins? Again you have to go for primitive, select box. You can see this wireframe model which has been prepared inside. So suitably take the dimension. Say for example in which direction you want your fin. According to that you can select the suitable dimension. Say for example X component you required that to be 30, so I will specify here 30. Y component I will require, say for example 1 centimeter, so I am specifying 1. Then Z component you required according to your we can say the we can say length of your fin, so I specified 3. Then I will slightly make it upward so that it will come here like this. Now I will shift this by Z component. Now what I will take 33 here, just I will take it 30 centimeters so that it will be exactly at the place which I want. So just check it out how the geometry has been prepared. You have got one fin at this end. So first of all add to frozen and make it generate. So this is one generated. Then I have to create many more such fins. So I am going to use a pattern. So select the geometry which you want as a pattern. Then direction. So carefully observe X, Y, YZ and ZX. Now XY direction cannot be taken because it is arrow in this direction. So just check it ZX. Yeah, this is a possible direction which we can take. So I am making it apply. Then offset by 3 centimeters. So I will making 3 centimeter. Number of bodies I want it for example 9. Then make it generate. So you can see this this has been generated over here. Same way you can generate on the other side. So there are two options. Either you can go with the mirror command or you can go with the pattern command itself. But for mirror command we might need to create a plane, and that is not good option if you want to create a plane here. So that will increase the time required. But I am just going for pattern command again. So select your geometries. So I am selecting, these are my geometries which I have used. Make it apply. Then select a direction. So carefully observe direction. So this is the direction which we don't want. We want opposite direction to this, like this. So make it apply. Then offset by 33 distance, say for example, and number of bodies I will say 1. Why? Because I have selected all, so that's why I have specified 1. So this is how you can observe the fins are also prepared on the other side. Now it's a time to have fins from other direction. Like if I want fins in this direction, how that can be obtained. So we'll see now. So first of all, again you have to go for the primitive, select the box. You can see the box arrangement over here. Then select respective, we can say x component to be equal to 3 centimeter over here. Then y component I will specify 1 centimeter as it is. Then z component, in this case you require 30 centimeter as it is. Now I will slightly shift this up over here, say for example 1. Now in this again z component you will specify, just check it out with 30 where it comes out. Okay, sorry, just a minute. Not a z component, I will specify x component over here, that is to be equal to 30. Just check it out where it goes. Okay, it is going exactly the place where we want. So now one fin has been created. You want many more fins like that. So how to do the same operation? Again you have to go with the pattern command. So select the geometry which you are interested in, make it select a direction. Just check it out which direction is suitable. Yes, this is the direction which is suitable. Make it apply. My offset by 3 centimeter. Number of copies I want at 9. Make it generate. So you can have this geometry has been prepared on this side over here. So make it add to frozen, so I have better visualization. Okay, so this is how I made as add to frozen. Now again you can go with the mirror operation or you can go with the pattern operation, but I am going to go with the pattern operation as the one which I have done earlier. So all geometry you have to select over here, make it apply. Then direction, just check it out, xy, yz and zx, whichever one is suitable you can select. This is suitable but I want reverse direction, so make it apply. Then at what distance I want, say for example 33 I want, make it a single body and then make it generate. Now just check it has come on this side also. So here also we have fin, here also we have fin, and we have fin from the all direction except at the top. There can be some errors if we are creating the top also, because the ANSYS has a limited version, academic version, so that's why number of operations which we can do are limited, and that's why I'm not providing the fins at the top, but I can also provide the fins at the top. So first of all, going for the boolean operation over here. So selecting all the bodies is important in order to proceed for the boolean operation. So you can just check it out. All the bodies has been selected. Make it apply 41, then make it generate. So all these have been unite. You can just check it out over here. Now once this has been generated, you can proceed for the next one, next work, that is by applying the boundary condition as and doing the other work. So let's move to the next part, that is related to model. Make it edit. So in the model itself we are applying the boundary condition. In model itself we are going to have the solution, and model itself we will be able to visualize the result. So that is the next part which is related to model. So all these remaining things are done in the model itself. So first of all, once the window is open, you have to go with the mesh option. So I'm just going to create a default mesh. I'm not generating mesh at my own because the system may take more time. So in order to reduce the time, I'm just taking the default mesh. So whatever the computer is generating the mesh at its own, the mesh may not be very good, but still in order to visualize the result, it is quite okay to go with this particular mesh. Then transient thermal analysis, I will apply temperature. So you have to select the geometries where you are applying the temperature. So I am selecting the internal surfaces, this one, this one, this one, and this one, and this one. So I selected 5 faces over there, and on these 5 faces I will apply temperature. So what temperature I am applying? Somewhere around 45 degrees Celsius. Then make it generate. Okay, so this is one thing which I have done. I have applied the temperatures. Then I'm going to go with the initial temperature as it is 22 degrees Celsius. Some time I will specify, say for example for 60 seconds. Then I will already have it specified temperature. Then I am going to see the result which we are wanting. So we want the temperature as a solution, and that's why I selected here as a temperature. So make it generate and just check it out how it can happen for your entire geometry. So depending on your system configuration, it may take time. Additionally, you can change the mesh size also depending on your requirement. But again, the configuration of the system needs to be taken into consideration when you are doing such kind of analysis. Say for say for example, if you don't want to, we say observe the mesh over here, you can select the no wireframe. In that case, this will be eliminated. Now we'll just check it out with running the simulation. You can see how the temperature variations are been taking place. Now this is a quite fast simulation, so I can select 100 frames and then I will select the 10 seconds. Now you can visualize it in better way, how the temperature variations are been taking place, how the temperature is reaching to the fin. At the top you are observing the highest of the temperature. That means the heat is more there and it is not able to dissipate to the surrounding because of the shape which we have provided. Whereas here, as the fins are provided, they are transferring heat quite quicker than the at the top surface. So this is how the visualization which we can have for the color variation which can show, that will show us the how the temperatures are varying over the period of time. So we have taken the time as a 60 seconds. In addition to that, say for example, if you want to visualize the initial values of temperature, that also you can check. Say for example, this is 45. What will be available here? This is 39. This is 40. Then at some internal part also you can just check it out how much temperature is there. So this variation in the temperature can be easily visualized with the help of this probe option available. Addition to that, you can visualize the maximum and minimum value of temperature where it is going to be, so that easily visualizations can be done. So this is how the analysis that can be done for an engine component. Like in case of two-wheelers, we observed the engine components are provided with the pins. So you can just check it out how much temperature we if we applied, what should be the heat dissipation, how the heat dissipation will be there. So that can be easily understood with the help of this particular analysis. Thank you.